So we did our last lesson over slope, and I just want to give a quick review before we do today's activity. And I just had a couple of graphs to review with and a couple of slope from 2 points. So if you guys recall that slope is always y over x, it's up and down over sideways. And Kyle always comes running in from the left. And when I go to pick 2 points, when they're not marked for me, I always look at the y-axis because a lot of times we have to write the equation and have the y-intercept anyways. So I noticed that right here is a point. So I'm going to go along that to the right because we read it left to right, and I found my other point. So how does Kyle get from this point to this point on the right? He goes up 1 and he goes over 2. 1 over 2. Remember, it is rise over run, guys. Up and down over sideways for your untechnical terms. So now let's go down and look at our next one. Our next one has points marked, and I always say you use the points marked even if you see others because it's going to be safer. So I now need to describe, because they're going to be exact, especially if it's not an exact thing. And I need to find out how Kyle gets from this point to this point right here. So I'm going to go on ahead and count. 1, 2, 3, 4, 5, 6, 7, 8. He goes down 8, which is a negative 8 over. And then he goes over to the right. 1, 2, 3, 4, 5, 6, 7, 8. And he goes over 8. That is going to reduce to a negative 1. I had a student ask me, do you always reduce them? Well, you're always going to reduce them as answer options. They're always going to be reduced. So it's definitely a way to get into the habit. Can you count down 8 over 8? Absolutely, every time. As long as you can count it on the graph, you're good. So now we're going to go down here. We're going to do a couple of them from points. I'm going to go up here first, and as you recall, I told y'all that I always use a T-chart. So I'm going to label my X, Y just for your reference, and I'm going to go on ahead and make my T-chart. So you plug it in horizontally, and then you go on ahead and you review it. How am I going to get from 3 to negative 1? So if you need to picture it, you're at 3, you go down to, I always kind of stop at 0, and then you go down to negative 1. So you went down 3 and you went down 1 for a total of down 4. Why do I do the y first? Because the slope is y over x. So I always do the right-hand side first since it goes on top. So now we're going to go over here and we're going to do x. How do I get from negative 2 to positive 2? So again, I'm going to go over here on the right and I'm going to visualize it. I go from negative 2 to 0 and I go back up to another 2. So that's up 4. So negative 4 over 4 reduces to negative 1. Now, I would also like to point out that this problem just happens to be the exact 2 points off of this problem up here. And as y'all note, it gave us the exact same slopes. So now let's go ahead and let's do this last example. So now let's go down and let's do our second problem. Okay, had to edit. I actually wrote down the wrong points, did the whole problem before I realized it. All right, so there's my 2 points, and I'm going to do the right-hand side first. And if you don't remember why, it's y over x. So I always tend to do the y first. And how do you go from 0 to negative 2? You go down 2. Then how do I go from negative 5 to 4? This one's kind of intense. So when I picture it, and usually what I do is I hold up my arm and kind of visualize it for you guys. But I go from negative 5 and I go up to 0, and then I go up to 4. So I went up 5, up 4 for a total of plus 9. That can't be reduced, so that is your slope.